Gentlemen, welcome back to the shop today. Treat especial, the prettiest ratchet ever conceived out of the inner city of Milwaukee. More likely Guangdong Namo Bay, China. I don't even know if that is that a I'm so old and I just don't give a shit. Is that offensive? Calling a ratchet? Could be. It's the Milwaukee half-inch ratchet. Electric, cordless, and so forth. What for? Busting nuts. Time. I like my ratchets like I like my coffee. Hot, black, bitter, and all up in my lap. This thing, as you'd expect any good ratchet to be pre-applied with another man's schmoo. She's proper greased up, nice and heavy in the hand. Weird balance, so, but you put a big bateria in there. I think that might be stout steel. Sure seems like it. It's quite heavy, meaty, girthy in the hand. 60 foot-pounds it's claiming on the box. Of course, the beautiful thing about ratchets, not that I'm the only one, is it's unlike a torque, an impact gun, because an impact gun, you're only going to get the torque out of it that you're going to get from the impactors. You can't spin the impact gun and get more torque out of it. But the ratchet, the reason I bought the ratchet is for running the vise on the milling machine. What I had been doing was impacting it in close just for speed and then tweaking it down. And it occurred to me, wasting time changing tools. Why don't I get a tool what will button it down and then I can tweak it myself? There's a clean off a dirty spot here in order to dirty up a clean spot. We'll get the clamshell off her, see what lies beneath the petticoats. Oh, and we got some anti-tamper Torx bits just to keep the non-determined scumbags out. Luckily, I ain't that kind. Jeez, oh, banana view. It's like they don't want us poking at her bit. I'm not even gonna get in there. Need to use the special. That's the cheapos from the Big Rock Candy Mountain. These are the Weras. J.A. Pan. I stink. We are. Oh, that come apart. Oh, that's got. Ah, I see. Tappy tap tap. Like this guy's some kind of butcher. I'm a busy fucking man. I got shit to do. No time to reach for a hammer. Quite a stout paddle switch on her. Light. It is steel and then powder coated. Bent, of course, punched and bent into. Aha! Trying to cock me over, the dirty ice holes. Fergin bastages. Quite a stiff clamshell. It's thick. It doesn't have a whole lot of gussets. You can see where it doesn't fit. Right there, mash that up on assembly, and also a little mold line here, a little sprue kind of looking thing, didn't quite match up. Also, we got excess of that blue Loctite PA6 glass fiber reinforced 30% with the SEBs and the TPS over molding here. In like sin and off the hop. Not much to beat on the value engineering side on this one, unfortunately. You know, you like to see a good product and you have her A part, and after a while you can see that the value engineering proposition has been in there to cheapify the price. Of course, they don't never drop the price of the tool. They just drop the price of cost of manufacture, and then you get a tool that just barely works. But in this case, we can see that compared to, say, 5 years ago when I started, maybe even longer than that now, started taking tools apart and having a peek under the petticoats to see what exactly was going on. There's some nice features that they just add standard now, but weren't in tools previous. One of the things, okay, so this is a brushless motor, so it's essentially a three-phase AC motor, and in order to take the 12 volts out of the battery and turn it into a three-phase for this motor to run, pulse DC into each of the three phase, well, yada yada yada. You gotta have some brain boxery, so you know intrinsically what is gonna fail. First off, the trigger switch where the rubber meets the load of the 200-pound gorilla. It seems quite stout, and also the locking mechanism to lock it out is very simple, and so not very many moving parts, so that shouldn't cock you over. What's gonna blast out of her, of course, is the brain box, or the silicon. You know, you're running a few amps through here at max torque, the thing's gonna get hot. There is some heat sinking on the backside through the vias. These are the Mosfets what actually do the switching. You can see paired up here for each of the 3 phases in the motor. There is probably an Atmel, or might just be, oh, now is that positively affixed? Well, I'll pull that out and we'll have a better, there we go. The Mosfets here, pardon my tremor, it's too early for medication yet. But the Mosfets, International Rectum Fryer, and the brain box is Texas Instruments. It's probably spun up specifically as a brushless DC motor controller with some ancillary sensoring and some analog inputs and stuff in order to take feedback from the Hall effect sensors in here. Hall effect sensors just measuring magnetic field of the rotor because there's a permanent DC magnets in there. That way it times. The thing is about these, they're very, well, people, okay, so I've been getting comments like, when are they going to start using brushless DC motors in plug-in appliances? And to my mind, that's utterly ridiculous, because you're adding another component. You're not are you really saving that much, you know, are you really saving that much energy? The energy density out of the wall, do you need more than a horsepower? And there's heat and all that stuff. But essentially, if you have a plug-in device, you want the old school dumb brushed motor, because you're not so worried about those kind of losses. It's no big deal. You'll forgive me my non-cicator here in case I'm jumping around and running the roads like a 3-ball tomcat. Busier as frig. So there's our planet gears, the sun gear, of course, being the pinion on the motor. These are all some nice heavy grease in there, and quite quite a bit of sticktivity to her. Can't get her out. Now this is interesting. This almost looks like a machined part. She got a gleam in her eye. Even you see past the schmoo. A pattern on this. Unless that's just a thrust. Oh, okay. That's just a hardened thrust chunk, a washer. And then this, you see the difference in the finishing here. You can see there's some copper on there and no copper on here. The moving parts apparently got a little more copper in the sintering powder than this guy. It's rather amazing to me that in these consumer commodity items, they have this powdered sintered technology down to such a level that they don't even need to machine this bearing boss. They can get the tolerance tight enough. And the only machining on this is just these threaded holes for the casement attachment. Had another poke and prod at her. It didn't, yeah. I thought I was, oh, focus, you fuck. I thought I was wrong. Turns out I was mistaken. They did have a go at her, and that has been turned. You can see, maybe you can and maybe you can't. That has distinct lathe marks from a carbide tool coming in there and cleaning up that bore. So not as technologically advanced as I figured. There's certain, you know, certain processes lend themselves to certain things, and you take a sintered bunch of material, you green press it, you cook it off, and then you sinter it together. It's going to shrink. So real tough to get that dimensionally super accurate enough for a bearing bore, as witnessed by the fact that they had to go in here and further process it on a lathe. Now, the powered ratcheting mechanism itself is quite ingenious. You can see on the output we increase the torque, everything is bigger, and all this is doing is spin-a-thinging. So it's spin-a-thinging, but it only spin-a-things in one direction. It doesn't reverse the motor. If you want to reverse, if you want to loosen off a fastener, you got to go in here and change the ratchet pawl over. So what's going on here is we just have a pin what rotates around here in this hip joint, and that spins this to and fro. But the beautiful thing is, because you have this ratchet and pawl, you have a one-way mechanism that in the one way it freewheels. If I can get the Jesus thing on here, I might be yeah, look at that. They've even made their own bearing race, hardened bearing race. Skookum. That's a heavy duty thing. You can tell this guy has been machined. You come in here with a mill and mill onto that shoulder, and then this part is turned, and then they installate this detent ball and put a press ring in there. So we got this offset crank chooching to and fro being driven by the brushless DC motor. You see in the one direction it's free to ratchet, and the other direction locks up. An ancillary benefit to this process becoming more a spin-off to this process becoming more and more ubiquitous is, sorry, tripping on my tongue triangulation there. I had to change mid-stroke. That's not easy for the most practiced of coitus interruptus. Ratchets are becoming more and more fine-toothed, which is kind of nice. You see this is probably a 20-year-old ratchet here. You see just the palm one doesn't see much use. But these older ratchets, of course, bigger chunks, older still, even bigger, like this guy. Until you get right up there to the old King Dick. This thing, but practically useless with a quarter turn of throw. Well, she's locked right up. You got to have a go at that again. But there's a fine line between super fine and too chunky, because I've been finding that the super fine new ratchets from the FAP-offs and the Mac tools and so forth, what happens is you chunk off one of these tiny little nubs, and this isn't tiny. This seems to be a good in-between size, so that you get a nice, decent throw, but at the same time, it's not so fine that if you just give her a bit of abuse, you end up peeling off just a tiny crest of that gear tooth. And it's not a big deal. It still grips and everything because you got more gear teeth. But the problem is that sliver gets cocked up in the works and you end up stripping a tooth out. Not because it's actually stripped, but because that thing is floating around in there. That's what I've been finding anyway. Just about to get this back together, and I'm quite sure I talked about the Texas Instruments and the International Rectum Fryer, the good components with a little bit of heat sinking through the body. There's over one glaring thing they got to change is this eye is too big for the wire, and it's also too big for the fastener. This comes down into here. Grounds the case probably eliminates any kind of hysteresis inside, or not eddy currents inside this casement of the bearing housing here for that high frequency. These things are switching real quick, switching polarity, magnetic polarity, which changes the electric polarity. You get weird shit happening here, so they ground it out. But the thing is, it's too big. They got to specify a smaller one of these. Look, it doesn't fill the hole, and it also doesn't, it just about comes over the top of the fastener. Of critical import to these high power density tools is the cooling, and they've omitted some. You see this, just this little wee fan here, and this is probably 300-400 watt motor. I'm going out on a limb here. I'm going to say it's probably running 300 watts, but they're counting on the fact that it's not going to be constant duty. The way you use a ratchet is you're not, unless you're in an assembly line, you're going to take out 5-10 fasteners, put in 5-10 fasteners, then you're going to put the tool aside. There's an innate duty cycle to this type of tool, and they're taking advantage of that by having just a small wee fan there. This is a very robust housing. You see the meat there, and also two big, nice long needle bearings for bearing on this this crank. This thing is not going to wear out mechanically, I don't think, unless you're really reefing on it. But the thing is about it, you're not going to be able to put a pipe on it. So it should last a goodly long time. I think the failure mode is going to be not wearing out the mechanical components, but this little circuit board. This circuit board's going to fry, motor's going to get hot, and of course the switch itself is going to crap out well before any of the mechanical components are going to fail. The other thing is, if you use a different battery, if you use that big Jesus battery, and then these things get chucked around, you quite possibly could break through the fixing mechanism, the bolting, and just break the housing. I don't think you're ever gonna smash, unless you purposely set out to smash this with a swing press. You're just not gonna break it. Whew! Thank fuck. Gonna ruin my record there. There's nothing bad to say about this. Nothing horrific to say about this. However, this little pin on this paddle switch, you see how much meat there is? Yeah. So on their grinder, same thing happened. Busted this guy off, clean out of the housing. So that is what's going to happen. That's a definite weak point for this guy. You get a big skookum paddle on this little itty bitty titty pin. It's going to break that housing, and should be flopping in the breeze, and then you'll just be running it like this, and then that'll break. The other thing I don't like about this, there's no bellows on this. In a machine shop, no problem. Automotive shop, that's going to be so full of conductive dust in no time. Break that, all kinds of, just detritus. Back together now, smoke them if you got them. We are going to do the smoke test. I think it goes in like that. And to reverse, it doesn't reverse the motor, it just reverts the ratchet. Now this is probably good for 50 foot-pounds. That's misleading though. You know how I know it's 50 foot-pounds? Because it says so right on the box. 60 plus minus 10. Yeah, marketing. You gotta give the allowances must be made. But it's not an impact gun. So the ultimate torque is actually how much this here square, this mechanism can handle. Because you can go ahead and reef on this and tighten her up way more than 50 or 60, what it says on the box. Just like using it like, oh, that's already pretty tight. Now the thing is about this, you got to watch, kind of a knuckle buster. So not even close. That might be the battery too, dead. Let's see if I can get her loose. And then, there we go. Fangaze. Oh yeah, it's telling me the battery's dead. The good thing about a ratchet is, versus an impact gun, is that even if the battery's died, you can still finish up busting your nut. Now this is a goofy little thing, but I like it. A light, what doesn't shine in your eyes, but actually on the work. A pulse width modulated dimming there. Ooh, the fence. It's a silly little thing, but come in handy. One thing I do not like is how open the countenance to that, fan is. You see how open that is? On a regular tool, it's quite closed up. You can't really get in there. Now that's not a fan on that, because that's making a, let's see. Something more like that. You cannot see the fan blades. You can't get in there with nothing to root it. I'm going to do my best to use and abuse this over the course of the next year. So then we'll tear her down, see what's starting to wear out, or if she makes the shift. If not, all the nothing like jumping on with glee on the carcass. Other than the piddly little bits here, she's reasonably skookum, despite the more orange look. They spend so much money on marketing, and then they cheap out on the dye for the injection molding, so it starts to look a little bit more orange. Thanks for watching. Oh, if and you have one of these, and you've been using the ever-living shit out of it, and you know what breaks, go ahead, please, down in a doobly-doo. I know on these M12 sometimes the battery starts to pop out, especially this thing gets tossed around. You know, you're under a vehicle and you finish the job and you just kind of smear it out while you creep out on your creeper. In any case, thanks for watching. Keep your digging advice. Couldn't tell if I was going to sneeze or fart on that one. Jesus. Don't ever catch old. It's fucking terminal.